3, 2, 1, and done. Today we're going to look at not just right-hand sums, but also left-hand, midpoint, and trapezoidal sums. Okay. I should have everything posted online by the end of today as well. I'm starting to get caught up. I do need to sub 8th hour though during my prep, but I think I should be able to still do a little bit of work during that time. So I just want to draw a picture of a general right-hand sum again. So suppose I have an interval here and a graph. I have the number 1, we'll go 0, 1, 2, and 3, so on and so forth. And for a right-hand sum, if I want to evaluate the sum between 1 and 3, I draw the rectangle at an x value of 2, and then I'll draw the rectangle at an x value of 3. And that is now a right-hand sum.
Have a new packet.
You don't have one yet? Or you need a new one?
I need a new one.
Okay.
I think someone ate it.
Okay.
Did you get hungry?
I think so. It's gone.
I had 2 during class.
I won't judge you if you decide to have a third.
There is more.
Oh, never mind.
Yeah.
Or you didn't say, did you want one? You said, did you get one?
I said, do you want one?
Oh, okay.
I felt bad, but there wasn't.
Okay. All right. Okay. Sure, I had 2 during flux. We're doing treat day on Wednesdays, which is also Happy Wednesday. We try to make somebody's day. So we made Team Taskers Day today. Send me a nice email. So.
What do you do on Fridays?
For my flex today.
What's that?
What do you do
No
on
teacher
Fridays?
showed up.
Fridays
so
we
we
do.
just walked to Henry's room.
What's that?
No teacher came for my flex today, so we walked to Henry's room.
Jensen
Okay.
gone?
Pretty exciting stuff.
We do play dates on Fridays.
I thought that was on Thursdays.
Thursdays?
Yeah, I thought that was on Thursdays.
Generally Fridays. Sometimes we do Thursday as well, depending on how adventurous we are. So, all right. So what about a left-hand sum? So I'm going to attempt to draw about the same type of picture here. And I'm going to mark off 0, 1, 2, and 3 again. And if I want to look at the area from 1 to 3, this time I draw the rectangle on the left-hand side. So the left-hand side, I would draw it at 1. And then I would draw it at 2. So notice how one of them gives you an overestimation and one of them provides an underestimation.
Mm-hmm.
Agreed? Okay. So if we look at the next one, the midpoint sum, I'm going to draw a very familiar shape again. And this one gets a little bit more confusing for people. For the midpoint sum, we draw at the middle of each interval. So notice we have the interval of 1 and 2 and 2 and 3 for each one. So what's the middle of 1 and 2?
1.5.
So I look for that to be the height, and then I extend it over and down, over and down. So notice how part of that is an overestimation and part of it is an underestimation. And we drew the height at 1.5. Similarly, if we draw the height at 2.5, again, we have an overestimation and an underestimation. So it is often the case that the midpoint sum is more accurate than the left hand or the right hand. And finally, the trapezoidal sum. We've already talked a little bit about this. But if I have this shape, 0, 1, 2, and 3. And in the red, I'm going to draw the left-hand sum. And in the purple, I'm going to draw the right-hand sum. Okay, so I have left hand and I have right hand. Neither one is trapezoid. But if we were to average the left hand and the right hand, would you agree that I get the blue shape? Which is the trapezoidal, which is obviously a lot better estimation, isn't it?
Where did you get the blue?
It looks.
So the blue, if I go ahead and if I look at the overestimation for the, if I look at the part of the purple that's extending further, and I cut it in half, which would be the average of the purple and the red. So if I do this, that kind of averages the purple and the red, doesn't it? And if I extend that down, it then makes a trapezoid shape. And so if we can think about what we did, we simply averaged the left hand and the right hand. So it so happens that obviously we know that the left hand and the right hand, so the right hand in this situation got evaluated at f of 2 and at f of 3. And in the left hand, it was evaluated at f of 1 and f of 2. The function was evaluated at 1 and 2, excuse me. At the midpoint, we evaluate the height at 1.5 and 2.5, halfway in between those pieces. And trapezoidal, for the most part, assuming that the widths are the same, we can simply just take the right hand plus the left hand and average them. We just divide by 2. So our goal today is to be able to find these 4 sums given a graph, given a table, and given a function rule. So let's start that together. This is the notation. This means right-hand sum with 4 rectangles. This means left-hand sum with 4 rectangles, midpoint sum with 4, and trapezoidal sum with 4. Okay. And so right-hand sum of 4 rectangles, what is the entire width of my interval? The entire width? 8. So if I'm dividing into 4 parts, what's going to be the width of each rectangle? 2. So I can simply take 2 times the sum of the heights. So I'm going to mark off my different intervals. I'm going to go from -2 to 0. I'm going to go from 0 to 2. I'm going to go from 2 to 4. I'm going to go from 4 to 6. For what x value do I evaluate my first height? 0, and that produces 1. And then I'll evaluate at 2, which gives me 7. And I'll evaluate at 4, which gives me 8. And I'll evaluate at 6, which gives me 6. 44. Now when I do the left-hand sum, I still have the exact same width, which is 2. Where do I evaluate my first height?
4.
I evaluate my first height at -2, which is going to be 5. Then I'll evaluate at 0 to get 1. And then I'll evaluate 2 to get 7. And 8, and where do I do my last one? 4, which I get 8. Yep. So you had said 4 right away. You kind of moved off to this side. So I'm still going to start at the -2 to 0 interval. It's just I look at the left-hand side. See that? Now notice that 1, 7, and 8 are part of each one, right? That is what they share in common, isn't it? So, and then obviously 6 is the last one. That doesn't become part of the left hand. And then 5 is part of the left hand, but not part of the right hand. As we add that up, we get 16 plus 5 is 21 times 2 is 42. So we already know the trapezoidal sum, which will be 44 plus 42, and we divide by 2, and we get a grand total of 43. For the midpoint, I have 2 times. Where do you think I evaluate the first height? At -1, and it produces 10. And I evaluate at 1, and I get 5. I evaluate 3, and I get 16, and I evaluate 5, and I get 5. So I have 20, 36, 36 times 2, I have 72.
So is that one like really inaccurate?
Yeah, if you look, this is a really, really erratic behaving function. If you look here, it jumps from 5 all the way to 10. It jumps from 7 all the way to 16. And so when we would look at this, we'd say, oh, wow, the midpoint is so different than the others. The only way to get a more accurate estimation would be, instead of doing the right hand of 4, do like 40 for each one. And that would give us a much better estimation. Increase the number of rectangles, and those should start to become more similar. Everybody see the big idea?
Yeah.
I will say that on this test, that's something that people, they get wrong. Okay, so as we come back to that, that's something you want to really make sure you get. Okay, all right. I don't think we need to do this one. Okay, we've already kind of seen that. Let's move to this next one, which is example 3. Okay, approximate the area bounded beneath the curve, -x squared plus 16, the y-axis and the x-axis in quadrant 1. And I want to do R of 5, L of 5, M of 5, and T of 5. So what would you do first if you saw this problem?
Plug it in my way.
Okay, plug in. What would you plug into your y equals? You mean you plug in the function so you can see a picture of the graph? Yeah, let's sketch that graph. And we know what this looks like. -x squared plus 16, what shape? Upside down parabola. It is, 16 units up. And actually, you know that it actually goes through 4 as well, don't you? So that's the exact area that we would like to find. I'll go ahead and I'll get a highlighter here. I'll highlight like this. That way our YouTube people, anybody want to say hi to anybody watching on YouTube right now?
Hi, Hannah.
Okay, so Lily says hi, Hannah.
Hi, Aaron.
Aaron is recognized. Jordan is recognized. Taylor and Zizi. We're not going to say hi to Aiden.
Hi, Aiden.
Allie got a hi to Aiden. Got a hi to Matthew. Okay, so there we go. So we're going to divide this into 5 parts. Right hand, what would you say? Did we miss anyone? All right. Emu, hi Emu. So we're going to divide into 5 parts. What is going to be the width of each rectangle if we divide into 5 parts?
4/5.
4/5. You take the entire width, which is 4, you divide it into 5 parts. We have 4/5. Whoop. Okay. So we have 4/5 times, and let's kind of work this through here, see how this is going to work out here. Where is the first spot if I use my right hand? Where's the first spot that I would evaluate a height? Yeah, I'm going to go 4/5.
Let's say like 15.
What would the next spot be? 8/5. After 8/5. 12/5. After 12/5. 16/5. And after 16/5. 20/5, which is 4. If I write that down, that produces everything that I need. I'm not going to actually evaluate this. We're just going to talk about what it is to plug it into your calculator. So we'd have 4/5 times, and you would do f of 4/5 plus f of 8/5 plus f of 12/5 plus f of 16/5 plus f of 20/5, which is 4, and that would produce your result.
Is that the same as plugging it into your table?
Exactly.
Okay.
Yep. Just for the sake of time, we're going to say that everybody pretty much understands that deal, right? Plug into your calculator, come up with the value, and we're good to go. So talk with the person next to you. How is it going to be different when we do the left-hand sum of 5? Talk, ready, set, go. Five, four, three, two, one. My first question, does the width stay the same?
Yeah.
Yes.
Yeah, it absolutely does. The width is still 4/5. Okay, and where do you evaluate your first height? Yeah, you start on the left-hand side of that interval, so we start over at 0. So f of 0, and we will still have the 4/5, and we will still have the 8/5. What will we not have? Yeah, you're not going to have f of 4. You'll stop at f of 16/5 because it's the left hand. And that will be L sub 5. The trapezoidal sum for 5 is simply going to be your R sub 5 plus your L sub 5 and divided by 2. That should be hopefully a pretty accurate estimate. How about midpoint of 5 rectangles? Is the width the same? Yeah, it's still 4/5. The width does not change. All that changes is where we evaluate the height. And so, what's that?
In the middle between each one.
What's between, yeah, 2/5. 2/5 is where you evaluate that first one. And then after 2/5 will be 6/5. After 6/5 is 10/5 or 2. And after 10/5, 14/5. And after 14/5, 18/5. Okay. And we could go ahead and type all those into our calculator and come up with values, but I'd rather just kind of get through this piece and then you can work on your assignment. So everybody okay with that? Okay. So now we look at a graphical approach here. Notice that we have this graph and we our bottom interval, it says is going from 0 to 120, from 0 to 120. The area that I am hoping to be able to identify is going to be this area region right here. Okay, that's what we want to be able to come up with completely. We're going to divide this area into 4 rectangles. And we're going to use those 4 rectangles to find the area. Some will maybe be an overestimate, some will maybe be an underestimate. I would like you to compute right now, if you can, R sub 4. Try on your own to do R sub 4. Give you a little bit of time to figure that out. Thank you, sir. So I had a width of 30. Everybody on the same page? And I had heights of 40, 80, 20, and 120.
Is it 100? Yeah.
Oh, sorry about that. Didn't quite look at the top there. So as I add that together, I have 120, 120 is 240, 240 times 3. I'm going 720. Is that correct? Okay, now 7,200. Thank you. As we do our left-hand sum, 30 will stay the same, won't it? And I'll just show you how we can make this a little easier. What number will we pick up?
0.
We'll pick up 0, and then we have 40, and we have 80, and we have 20. What number do we lose?
100.
We lose 100, right? We lose 100. And so 40 and 20 is 60, plus 80 is 140. 140 times 3, 30, 4,200. What can we now compute? Trapezoidal sum will be the average. The average will be 5,700. Let's compute the midpoint. I choose the middle of 0 and 30, which is going to be 15. As I draw that height, what is my height? It is 20. So I have 30 times 20 will be my first height. And sometimes people say, should these be exact? If it's a line, yes, it should be exact. You can see that in this situation, you should be able to find the middle of those two heights, and it should be at 60. What's the middle of the next height?
50.
It is 50. Good job. And the middle of the next height is 60. Wah, 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 wah. And I have 60 plus 60 is 120, plus 50 is 170, plus 20 is 190. 190 times 30 is 5,700 as well. And so it turns out that the exact area is 5,700.
Kind of looks like a 2, but it's okay.
That's an excellent point. Rhea interjected and said, looks like a 2. And my pen did drag a little bit. I'll go back and rewrite that. We wouldn't want an angry Rhea.
No, I wasn't angry, but people online.
I could see the anger in your face.
Is that why you looked back at me?
Yeah.
The same thing.
Which, by the way, today I am a purveyor of positivity, and I am trying to make sure that everybody has an available date for prom. So as you look at my board, I have brought back the list of those who are available for prom. If you need your name added to the list, I will do so. Right now is the time of year where girls are starting to buy dresses and guys will not think about prom for another 10 weeks, okay? And so we need to rush that along. So I also have rankings for each individual on the side, okay? So Megan Johnson, she's pretty an awesome person, right? Yeah, go Megan. So she's got a solid 9.5. Chet, 8.1, because he's not taking a math class right now.
But he has
Okay.
money.
But he does
But he
have
has
money.
money.
Yep. Josh Jordahl, 9.9. He comes with curly hair.
It's fake, it's sperm.
Callie Studier, 9.3, because she will not help pay, but she does already have a dress that's supposed to be really nice. So, those are things that you can think about. So, anyway, if you like your name added, just let me. Anybody want their name up on the board right now?
Alex does.
Alex.
Yeah, Alex.
I'll have my name.
Addie.
Yeah.
Okay. So, Addie's on the board. Anything we should put with Addie's name?
Oh no.
What's your costume?
Do you have your dress yet?
No.
Do you have you thought of your dress?
Mm. You spelled my name wrong.
Honestly,
Did you
Chet
say
and Callie
Callie?
are-
No, the E.
There you go.
Okay. Will we not agree solid 9.9?
She
Um,
doesn't have her dress yet.
And I would say what comes low maintenance.
That's true, that's true.
Wait, I mean, come on, right?
We can put my name up there, Mr. Hintz.
We got Hattie Adams, another calculus student. We've got to go with a solid 9.9 again.
Yes.
Okay, what do we got for Hattie?
Sorry, what is this for?
Okay,
Prom.
she
Do you have your dress?
will
No, I'm
not
going February 4th.
be taller
Oh my god.
than her date. Okay, well, if you're going for the height issue, there, it's out the door.
Throw me up there,
Okay.
yes.
What's that?
Yeah,
What
Maggie
does
doesn't
what
have
does
any.
Ava have?
Lily, Ava Murray?
Yeah.
No, nobody said anything, so we're just going. Lily Christinger,
She's 9.9 again.
okay, at 9.9er. And what does she bring to the table?
Also short.
I wear heels, it's okay.
Do you have your dress?
She will make you laugh. That will happen. Yeah, so you can go ahead and search the board, and if you are somebody who recently put your name up here, maybe you see a name up there of somebody who could be asked. So there's all sorts of people. One person did get a 3.2 because they say that he's a liar. So
They said Josh is alive?
No, they said
Jacob Miller.
Oh,
Chet and Kelly could go together. Kelly needs money and Chet has money.
yeah, exactly. That's what I'm hoping. Like I'd like to bring people together. Like to bring people together.
Well.
All right. Okay. So what we want to do now, and this is the last piece before tomorrow, we're going to do the incredible task of adding up the area of an infinite number of rectangles. Notice so far that we've had like 4 rectangles or 8 or 2. Are you scared of an infinite number?
Terrified.
Terrified. Ooh, wow.
Yes.
It's pretty amazing when you see it. What I would like to do right now is I would like to use graphing technology to show you how to do 100 rectangles. Would we all agree that you don't want to do 100 rectangles by hand?
No.
So we will not. And we will start with right hand sum of 100 rectangles. And we're going to look at the area boundary between the curve f of x equals sine of x and the x-axis over the given interval 0 to pi. What does the graph of sine of x look like? What is the period of sine of x? 2 pi. So what is halfway?
Hi.
Pi. So therefore, you guys already know, you've seen this, you pictured it in your brain because you were super smart and you had a great college trig teacher, that we are simply looking for that portion of the graph, that area. Interesting question, right? We like to divide up and do how many rectangles?
100.
100 rectangles. So what would be the width of each rectangle?
Pi over 100.
Pi over 100. The width of each rectangle is pi over 100. So if this spot here is 0 and I move over one width, what would this spot right there be? Pi over 100. What would the next spot be?
2 pi over.
2 pi over 100. And so on and so forth, right?
Uh-huh.
What is the last spot?
Pi.
99 pi over 100.
Okay, so 99 pi over 100 and then 100 pi over 100, obviously known as pi, agreed? So notice how I always like to try to come back to the tick marks on the bottom. That's where I generate my information, okay? Everybody got that? All right, so when we type this into our calculator, there's a special formula that I like to use to do this. And this is something you'll need to be able to do on the test. So please know it so you don't have to ask me how do I use my calculator in a scenario. And here's what you do. You do the width times the sum of the sequence of the function. Name the variable, name the beginning, name the end, and name the width. That formula I will give to you, but you must know how to use it. You must know how to access it on the calculator. We all good? So let's first write down what we're going to type in. And so we have the width, which is pi over 100. And then we'll type in sum and sequence. I'll pause as everybody gets to that spot. So all we're doing is the same thing we've done before, we're just using our calculator. Remember before we used to take our width times the sum of all the heights, right? So that's what this is. It's the width times the sum of the heights. We need to tell our calculator what the heights are. Well, how do you determine the heights? Yeah, you plug in your x values into the function, right? So we got to tell what's the first x value we plug in, what's the last x value we plug in, like how far do we go in between each x value, and you just go one width each time, right? And what do you plug those into? You plug them into the function. And this just tells you that we need to use x as our variable. So that's what it's telling you. So that's how we generate the height. So we're going to take out our calculator. This is where it gets super exciting.
Yay. Alex is so excited.
Me and Rhea are very excited.
Like, what? Very awesome calculator. Alex is probably really scripting.
Correct.
So we currently have a couple of people who do not have a calculator, so we're going to
Thank
intervene
you.
in this moment. I will be teacher of the year.
Alex told me he has a calculator in his brain and he doesn't need to use a calculator.
Alex did not say
You should
that.
probably get Hanson and the calculator then.
It's in the car door
Okay.
of my car.
There you go.
Because I keep forgetting to take it out.
Well, it's not here right now. So.
Because I was doing math in my car.
All right, so here we go. Let's try type it in. I go pi divided by 100. Very good?
Yeah.
We need to do sum of the sequence. Now, before we go to the sequence, because it involves sine of x, let's make sure that we are working in radians and not degrees. That's more for me because I'm in trigonometry right now teaching, and it's a constant back and forth. Okay, times the sum. How we get sum is we go into our catalog, which is 0. So second, 0. And notice how it goes to the A's. I press S, so it goes to the S's. I'm sorry.
Let me find the letter for other.
Wait, so you do alpha S?
So the green letter S right here is on natural log. You just press that and it'll jump to the S's for you.
Do you have to push alpha to go with it?
Nope.
No, okay.
And I get to this sum.
Wait, I still can't get
So press that button. Oh, yours isn't jumping, so we're just going to go second catalog, and now we're going to type test for sum. Yep, you could have just pressed T and then gone the other way. That would have been an option as well. So I press sum, enter. Are we okay?
Mm-hmm.
And now I press sequence. I got to do the same thing. Second, catalog, I press S for sequence. And you want to grab the sequence with the lowercase s.
What's the difference between the two?
Not really available right now to share.
Okay.
Sorry. What is our function? So we type in sine of x, close that parenthesis, and then the commas are important. So then we go comma. We have to name the variable. What's our variable? X. So we name x, comma. We begin at pi over 100. Pi divided by 100.
You don't need parentheses around that?
Nope. Where do we end? Pi. And then what is the width? Pi divided by 100. And don't erase this. We're going to use this again so that we don't have to go through all that rigmarole. Okay? So I press enter. And I get 1.999835.
Whoa.
I'm going to type it again, what I put there, because we talked about it. I want to make sure people online see it. Again, sequence was, we put in sine of x, and we put in x. our beginning was pi over 100, our end was pi, and our width was pi over 100. And we got a value that was really close to 2. It turns out the exact value is 2. But that would be the right hand. Notice how accurate we are. It wouldn't be much work to increase the number to 1,000, would it? Nope, and they could become even more accurate, okay? And so notice that your calculator, when it does that area calculation, it comes up with an approximation as well. It probably just creates 1,000 rectangles. Probably does a rectangle for every pixel or something. Get my point? So it's just using the same iteration. So let's do left hand of 100. Don't erase anything on your calculator, okay? What's going to change? I'm still going to have pi over 100. I'm going to have the sum, and I'm going to have the sequence of sine of x. What's going to change? Starts at 0. Where does it end? 99 pi over 100. And the width is still pi over 100. So on your test, I want to see what you've typed in. Everybody clear with that? Okay, so I'm going to take that, and I'm going to go to my calculator, and do not press clear. What you're going to do is you're going to press second enter, and that brings up your previous entry. And then you could go back and change that to what you want. So I'm going to go back to the pi over 100, and I'm going to type in 0. Comma, that's going to go to 99 pi divided by 100. Comma, and then the width is pi over 100. And a couple parentheses there.
How do you get the whole thing clear?
You want to clear everything?
No, like.
So you just press delete, like that. Yep.
And then wait, so that's the same, and so this is 0.
0, and then
this
pi, or 99 pi over 100. Comma, and then pi over 100. And I press enter on that, I get 1.998848. And be ready for me to ask for answers out to like 6 decimal places, because obviously the first two, they're the same. So I want to see the difference. Okay. What could I calculate right now? So the trapezoidal sum, I don't have to do anything other than just average them. I'm not going to do that right now because then I'll lose the entry in my calculator. Okay. But finally, let's end today. You guys have done a great job and we're going to end with the midpoint sum. So I still have pi over 100. I still have the sum, and I have the sequence. I have sine of x. I have x. Where will I start evaluating?
1 over
Pi over 200?
Yeah, pi over 200, right? Now, if you're confused about that, I want to be clear about the definition. It is the midpoint. And the way we find a middle is we take the two, we take 0 plus pi over 100, and we find the middle of them, or in other words, we average them. And if you average those two values, you would come up with pi over 200. And so if you look at your last ones, which are 99 pi over 100 and 100 pi over 100. If we were to find the middle of those, watch, I have 99 pi over 100 plus 100 pi over 100, and I would divide by 2. What would you get in the numerator? 199 pi over 100. When you divide by 2, it will be 199 pi over 200. Does that make sense? Okay. So 199 pi over 200. And the width is still just pi over 100. What do you think sometimes people write for the width instead of pi over 100?
200.
They write pi over 200. Do you see why they would do that? Yeah, and in fact, that is not accurate. The width stays the same. And so we could go in and we could go ahead and make that adjustment. I press second entry, and I get the same expression that I had earlier. I start at pi divided by 200, comma, then we went to 99 pi divided by, excuse me, yes, 199 pi divided by 200, and then comma, I had obviously pi divided by 100 is that width, and I press enter to that, 1.999588. And for the trapezoidal sum of 100, just take L of 100 plus R of 100 and divide it by 2. Could you please glance at your homework before you leave? So I really did want to get this all in. And the reason why is because the next kind of lesson we do, it takes us 3 days. So over the course of the next 3 days, you're only going to have 1 new homework assignment. So I want to make sure you had something else you could work on. You get my point? So if you would look at this page right here, okay, which says right-hand sum, left-hand sum, trapezoidal sum, notice the first one, how many rectangles do you have for problem 1? 3, so you do those by hand. How many rectangles do you have for problem number 2? 5, do those by hand. Use your calculator a little bit if you need to. But everybody see for number 5, you were asked to do how many triangles or how many rectangles? 50. So if you're doing 50, you are using this calculator technology. So if you're asked to do a significant number of rectangles, then go ahead and do this. Get my point? Okay, so you can look through that. You do want to try to get a little bit of that, but the next lesson takes us 3 days. Good job. Way to go. Hope you find a day for prom.